Tunnels of this diameter are normally mined in 3 sections. First, the top section, the crown, is excavated. Then comes the middle section, and finally, the floor of the tunnel, the invert. Once the entire tunnel had been excavated, work was started on constructing the inner lining of reinforced concrete, starting with the reinforcing and concreting of the floor of the tunnel. Although the project had already involved the use of several thousand cubic meters of concrete for the site installations, the camp, the bridge, and various other things, the concrete poured for the first tunnel floor was the first batch of a total of 200,000 cubic meters permanent structural concrete used for the Randenigala project. The production of the concrete was of crucial importance to construction operations. In the Randenigala area, there are no adequate supplies of natural sand and gravel suitable for making concrete. The aggregates for the concrete, therefore, had to be especially produced in a crushing and screening plant on the site. The rock excavated from the building pits and the tunnels was taken to this plant, where all the requisite grain sizes ranging from sand to gravel could be produced. The addition of cement and water and the mixing of the fresh concrete took place in a stationary large-scale mixing plant. When placing concrete, particular attention must be paid to the temperature. Too high a temperature, combined with the heat subsequently generated by the concrete as it sets, can cause damage to the structure. In tropical countries, it is therefore especially important to ensure that the permissible maximum temperature for the fresh concrete is not exceeded. In Randenigala, no special measures were needed to cool the concrete during the cooler months of the rainy season, but during the summer, a whole range of measures had to be taken. The first step was spraying the aggregates with river water, that is, cooling by surface evaporation. A second step was the artificial cooling of the mixing water for the concrete, and a third step, which could be resorted to if necessary, was adding ice flakes to the freshly loaded transport vehicles. This meant that it was possible to adapt to the prevailing temperature and that the site could always be supplied with sufficiently cool, top-quality concrete. The reinforcement of the tunnel sections depended on the quality of the rock. In as far as reinforcement was necessary, reinforcing mats were mainly used. The formwork for the arch of the tunnel was erected with the aid of a steel formwork transport wagon mounted on rails. With this, the formwork for the entire arch, as from the upper edge of the floor, could be erected for one tunnel section at a time. As it did not take long to move the formwork wagon from one section to the next, it was possible to achieve high working speeds. In addition, the stiff, dimensionally stable